responsible for the treatment of organic waste in the capital area of Finland. I'd like to tell you a little bit about our pyrolysis project for sewage sludge and the experiences with the test plant we have been building. Why is it reasonable to treat sewage sludge with pyrolysis? One reason is that we can improve the image of the sewage sludge products by the treatment. One point is that we can eliminate possible organic pollutants in the sludge, which have been mostly a reason why these products haven't been used. Secondly, we have good conditions for the sanitation of the sludge, and the starting discussion about microplastic leads also to bad image of the sludge, and this can be eliminated also due to these high temperatures we have in the treatment. It enhances the circular economy in that aspect that the nutrients can be recovered, especially phosphorus and nitrogen, but it also recovers a part of the carbon. Compared to incineration of the sludge, the part of the carbon is still left in the product. And we have a minimizing of waste because there are nearly no rejects. It improves climate change mitigation by not emitting so much carbon as, for example, in the incineration. And the second part of the carbon, which is still left in the product, is also very firmly bound. And also the economics of the sewage sludge pyrolysis is reasonable. How did we start with that project? First, we had some tests in the year 14 and 15 already with wood biochar in the biowaste treatment. We tested it together with this biowaste in our composting plant and found out that it improved the process very much. Then we had the necessity to get more treatment capacity for sewage sludge, and we wondered about different technologies, how we could realize this new capacity. In 2018 to 20, we had tests of pyrolysis of sludge in another plant, in a smaller plant, where we also made analysis of the process itself and of the end product. Afterwards, we decided to build an own plant, which should be a small model of a possible big treatment facility. In the last year, we had a testing phase of this plant. That means that we operated it with sewage sludge and then analyzed the results to get finally to the possibility to see also how a big plant could be dimensioned and planned and designed. This is how our pilot plant is working. It was for 3,000 tons of sludge and an additionally amount of green waste or wood chips. So the sludge was fed here in a bunker, and the wood waste here, it's about 20% of the whole amount was wood waste. That was chosen for that reason because we wanted to be self-sufficient in heat production, and the sewage sludge pyrolysis doesn't give enough heat for that. And the second reason was that end product quality, the carbon content, is also risen by adding wood waste. These both materials are dried under a temperature of 120 degrees, and the exhaust air from there is first put to a acid spraying, acid washer. That means that ammonium is washed out and is transferred to ammonium sulfate, which is then stored in a tank. The air is continued to a biofiltration, where the odorous compounds of the air are removed. The dried mixture is then fed to a bunker, to a buffer, from where it is going to the pyrolysis drum. We choose this drum because it can be easily scaled up, also for a bigger plant. In this test plant, the drum was designed like that we can have a very long retention time, from 30 minutes until 2 hours, and also the temperature can be varied from 450 degrees to over 600 degrees, because we wanted to test different temperatures and retention times in our pilot. We created sludge jar. This is first cooled in a conveyor and then sprayed with water to avoid that it's incinerating, because it's very active, and if it's getting into air, then it might be possible that it starts to burn. During our tests, we found out that we can also use the ammonium sulfate, which is produced in the exhaust air cleaning of the dryer, so we can recycle the nitrogen into the end product. So all of this ammonium sulfate can be recycled in that way. Then we get, of course, the pyrolysis gas, and we aimed for a total utilization of the gas. We wanted to avoid condensation of tars, on the way from the pyrolysis drum to the burner. So this transporting distance is very short, and we are also heating this pipe to avoid the condensation. The flue gas from the burner is then cleaned in a bag filter. This is a quite simple system, which we would enhance when we would build a bigger plant, because then it wouldn't fulfill maybe the legislation, because it's then seen as a waste incineration plant. Something about the end product now. We have analyzed quite a lot there and found or analyzed about 174 different organic compounds in the char, and one result was that most of these organic contaminants were totally eliminated or reduced, at least so much that it can be accepted. Then the PAH 16 also, and the dioxin and furans were below the values which are in the legislation. No microplastics were left. At that temperature of over 500 degrees, it's quite sure that also the plastic can be carbonized. Of course, you get a concentration of the heavy metals, except for the quicksilver and the cadmium, which are partly evaporated, but the concentration was not rising so much that it didn't fulfill the finish limit values. So it's still utilizable as a fertilizer directly. And additionally, we found also that these heavy metals have a quite low solubility. That means that it will not release from the matter. Carbon balance is getting more and more important for all treatment and production processes. And the nowadays treatment is the windrow composting, where we have about just 18% of the carbon left in the end product, in the compost. Then in comparison, the pyrolysis leaves nearly 60% of the carbon. So this is a big argument for the pyrolysis process in the future. Here I show also a mass balance for other ingredients. You can look at it later on. I will not explain that in detail now. How can we utilize the char? This was also examined during our test and partly ongoing still. So there is a main possibility to utilize it in the composting. We had already positive effects of utilizing wood char as a part of the composting process of biowaste, and we got in principle the same results also with a sludge char. That means that the process is getting faster. The maturity of the compost is coming sooner than without this addition. The next process where we tested the biochar, the sludge char, is the biowaste digestion. There we also found out that the addition gives a more stable process. It's more resilient to process change and to different feeds. Stormwater filtration has been started to test. We have an area where we have different substrates for this stormwater filtration plant, and one is including also the sludge char. And then we have tested it as a direct ingredient in substrates, which gave also positive effects. We don't only add carbon but also nutrients with the char. And at last the char can be utilized as a fertilizer directly, but for that we need a certificate from the authorities, and this is in progress at the moment. What did the plant what did we learn from the operation of the plant? We have in future a temperature of about a little over 500 degrees. This was quite the optimum. There was not so much changes in quality of the char with varying the temperature, but this temperature makes sure that also, for example, plastic is pyrolyzed. The retention time doesn't have to be very long. The pyrolysis of the sludge was very fast, so 30 to 40 minutes is enough to get a good end product. The process can be self-sufficient. This plant was very small, and of course through that we had a lot of heat losses, but it seems that we anyhow need some additional material like wood to get this self-sufficiency. And I told you already that this stripped ammonia can be recycled and brought into the char, so it also rises in nitrogen content. One problem was that dust was created in the systems and sedimented there, so there were some works to clean the system, but this has to be just taken into account when a bigger plant is planned. This is not something which will be difficult to solute. And we had very few waste of the treatment process. This is a real recycling process where most of the material goes back to utilization. Just 1 promille was this fly ash, but this is then hazardous waste. We have the possibility to scale up. We are sure that a bigger plant would also work properly, and that we can solve these small problems which have still has appeared in the operation of the pilot. Thank you very much for your attention.
Thank you for your presentation, Christoph. I wanted to just make it clear, because at the presentation it said that sludge biochar logs 30% of.
Yeah, there was a mistake. I had to correct
60,
at the end.
So I wanted to make it clear which number is true.
There was a mistake. I had to correct it afterwards, but I didn't change my video anymore. So it was 30%, but it's nearly double of that what is saved in the composting process.
Wants to know which drying system or technique is used and how much energy is required for it, and can this be covered by generating electricity from the pyrolysis exhaust gas?
We have a belt dryer, and I have to admit that I don't know a figure about the energy or the heat consumption in that belt dryer, because we had connected it directly to the burner of the gas. We didn't measure how much energy was blown into that system. And you asked about electricity production. A question of how do you think electricity production should be made with the exhaust gas or with the pyrolysis gas?
Well, it's not exactly specified from the pyrolysis exhaust gas. So yeah, maybe with a RRC cycle, maybe.
Yeah. We were of the opinion that the best way to utilize this pyrolysis gas is the incineration, and we tried even to avoid that oil production in the when the pyrolysis gas is condensing or cooling. So we had that heat anyhow, and we would utilize that also like that in the future. Electrical separate heating of the system is, in our opinion, it would be possible, but how would we use the pyrolysis gas then? We would anyhow incinerate it, and then you get heat. Then it's a little bit the question, why do you heat the system then electrically? It's possible, of course.
Any more questions? All right, that's it.
No questions from the audience. So one question from me. So you told us that upscaling would be a good idea. So are you planning already to make this upscaling plant coming true?
Yeah, there are two reasons why we don't start immediately to upscale. One is that the market situation for compost from sewage sludge is still quite good, and it's getting even a little bit better because of the high nutrient prices or fertilizer prices through the Ukraine crisis. That is one reason we wait still until the market situation is changing or the legislation is changing. And the second reason is the size for upscaling in our case would be very big. So our company is producing about 100,000 tons of sewage sludge every year, and that would be a very big plant. So we are a little bit hesitating to scale up from a 3,000 tons plant to a 100,000 tons plant. So we in principle a little bit like waiting for others who pick a medium-sized plant first to see their experiences before we go to a very big plant in our company.